All right, now let's talk about determining statistical significance of a correlation. We're going to be doing more of this significance testing in the last third of the course. This is our first go with it, with correlation. We're going to use the R table to determine significance. One shortcut version of determining significance is something called the coefficient of determination, or just R squared. And when you calculate the R squared of a correlation, like our negative 0.92 value for our depression and self-esteem scores, this means that 85% of the variance of our depression scores can be explained by the variance of our self-esteem scores. So that gives us a rough estimate of how close our two variables are. The R table gives us p-values and measures levels of significance. And there are some things we need in order to determine the significance. The first is degrees of freedom. It is quite simply a formula that is n minus 2. N is the sample size. For our example, sample size was 8, so our degree of freedom is 6. And if you look at the R table, degrees of freedom is this column, so we'd be using this row of data. Our significance is somewhere in this row of data. Then we go on to one- and two-tailed hypotheses. This is just whether your correlation is predicting an outcome, a directional outcome or not. Are you predicting a one-tailed test or a two-tailed test? One-tailed test suggests that you are predicting a direction of outcome. You're predicting a positive correlation or a negative correlation. If you're predicting no correlation, no direction of the correlation, and you'll be happy either way it turns out, positive or negative, that is a two-tailed test. So if you allow positive or negative two-tailed test, if you're predicting one outcome, a positive correlation or a negative correlation, we have to use this one-tailed bar. The next thing we need is the levels of significance, but these will be given to you. You can't calculate these in any way. The standard default value for levels of significance are 0.05, but I will state the levels of significance I'm requesting for in the problem. Once you have those four things, then all you really need is to determine the critical value. So if we go to our problem was a one-tailed test. It predicted that there would be a relationship, a negative relationship between depression and self-esteem scores. If the question was at 0.05, say what is the significant level? At 0.05, well, we know I have 6 degrees of freedom, and our significant value is 0.622, and this is a threshold value. What this means is if our correlation is larger than that number, then it is significant. And ours is. In this case, we ignore the negative. The negative is just showing a direction. So based on our criteria of a one-tailed hypothesis predicting a direction of outcome, of 0.05 significance value, a sample size of 8, which would give us degrees of freedom of 6, this is our critical value. Our calculated R surpasses this critical R, and so we conclude that our correlation is significant.